You've probably spent decades using air conditioners, but the truth is, they don't actually create cold air. Instead, they simply move heat from one place to another. The secret lies in a substance called refrigerant. At normal atmospheric pressure, it boils at temperatures well below 0 degrees Celsius. As it evaporates, it absorbs a tremendous amount of heat. So, when it evaporates inside the room, it rapidly removes heat from the indoor air. But once the refrigerant evaporates, it becomes a gas. So, how do you turn it back into a liquid so it can keep absorbing heat over and over again? The answer is to compress the gas. Inside the outdoor unit of an air conditioner is a scroll compressor. It contains two spiral-shaped scrolls, one fixed and one orbiting. Gaseous refrigerant enters from the outer edge and is gradually forced toward the center. As the space between the scrolls becomes smaller, the gas is compressed into a denser state. Finally, it is discharged from the center. A gas that started at around 30 degrees Celsius is compressed until its temperature rises to over 80 degrees Celsius. This extremely hot gas then flows into a network of copper tubes called the condenser. Heat passes through the tube walls and is carried away by a fan blowing air across the coils. As the refrigerant travels through the condenser, it cools and changes from a gas into a liquid. By the time it leaves, it has become a high-pressure liquid at about 50 degrees Celsius. It's similar to the way steam from a boiling pot condenses into water droplets when it touches a cooler lid. However, 50 degrees Celsius is still much too warm to cool a room. So how does the refrigerant become cold enough? This is where the most important step takes place. The liquid refrigerant enters the expansion valve, which acts like a faucet with a tiny opening. As it is forced through the narrow passage and suddenly enters a much larger space, its pressure drops dramatically. With that rapid pressure drop comes a sharp drop in temperature. In an instant, the 50 degrees Celsius liquid becomes a cold mist at below 7 degrees Celsius. The refrigerant then enters the evaporator coils inside the indoor unit. As it evaporates back into a gas, it absorbs heat from the surrounding air. Meanwhile, the indoor fan blows the cooled air into the room. That's the cool breeze you feel. But how does the air conditioner maintain a constant indoor temperature? You'll find that the expansion valve is connected to a slender temperature-sensing bulb attached to the outlet of the evaporator. This bulb also contains refrigerant. When the temperature of the evaporator outlet rises, the refrigerant inside the sensing bulb boils, increasing its pressure. That pressure is transmitted to the expansion valve, causing it to open wider and allow more refrigerant into the evaporator to absorb additional heat. When the outlet temperature falls, the pressure inside the sensing bulb decreases. A spring pushes the valve toward the closed position, reducing the refrigerant flow. This continuous adjustment keeps the evaporator operating at its optimum condition, allowing the room temperature to remain stable. Finally, after absorbing heat from the room, the refrigerant returns to the compressor as a gas at around 30 degrees Celsius, where the cycle begins again. Throughout this entire process, the air conditioner never creates cold. It simply transfers heat from inside the room to the outdoors. Congratulations, you've just invented the air conditioner.